In this video, we're going to talk about atomic structure and the atom. So in order to do that, we need to talk about the periodic table. So Dmitri Mendeleev is credited with creating the first version of the modern periodic table. The periodic table is a chart showing all the elements arranged in columns in such a way that all the elements in a given column exhibit similar chemical properties. The periodic table is organized in order of increasing atomic number. The periodic table is organized in columns, which we call groups or families, and in rows that we call periods. The periodic table can be divided into metals, nonmetals, and metalloids, where you can see metals in blue make up a majority of the periodic table and are primarily all on the left side of our periodic table, with the exception of hydrogen, which is a nonmetal, like the other gold nonmetals that are primarily found on the right side of the periodic table. Then we have our metalloids. And you can see this red stair step right there. That stair step is what separates the metals from the nonmetals. And anything touching the stairs is a metalloid, with the exception of aluminum, which is just a metal. But everyone else touching the stairs is a metalloid. You need to know nonmetals versus metals and metalloids. So what are some properties of these? So metals are lustrous, meaning shiny. They are malleable, which means they can be hammered into thin sheets. They are ductile, which means they can be pulled into wires. They tend to be hard, and they tend to conduct electricity. On the other hand, we have nonmetals that do not conduct heat or electricity very well. They tend to be very brittle, meaning they break easily, and they are also not easy to mold into different shapes. So they're kind of the opposite of metals. But what about metalloids? Metalloids have properties of both metals and nonmetals that vary with the specific metalloid. As I mentioned before, the columns on the periodic table are called families. The family name can be divided based on our on the period. So our first column here is our alkali metals. Our second column here is the alkaline earth metals. Everything in this lower middle section is our transition metals, 3 through 12. Then group 13 is our boron group because it starts with boron. 14 is our carbon group because it starts with carbon. 15 is our nitrogen group, you guessed it, because it starts with nitrogen. And 16 is our oxygen group because it starts with oxygen. However, then the pattern changes a little bit. Family 17 is called the halogens, and then family 18 is called the noble gases. The two bars down at the bottom of the periodic table also have numbers, with the first row down at the bottom being the lanthanides, and with the second row being the actinides. You are responsible for knowing these family names and which column on the periodic table they correspond to. So elements in the same family have similar properties. So all of our halogens have similar properties, just like all the alkaline earth metals have similar properties. The alkali metals, which if you remember were over here on the far side, are the most reactive metals, and the halogens, which if you will remember are over here, almost all the way on our right side, are the most reactive non-metals. The noble gases, however, that very last column, are inert, meaning they do not react at all. So they do not react. So where are all these elements even coming from, though? So all elements after hydrogen were created by a process known as nuclear fusion. Nuclear fusion is a nuclear reaction in which two or more atomic nuclei, we'll talk more about those later, collide at nearly the speed of light and join to make a new type of atomic nucleus. This creates newer and larger elements as the nuclei collide, creating larger and larger nuclei. All elements from helium to uranium, you learn them all for your periodic table test, occur naturally due to the nuclear fusion that's happening in the stars. So they are brought to Earth from the nuclear fusion that has occurred in stars. However, all elements that are past uranium on the periodic table are man-made, where we have created the nuclear fusion reaction that has created the new elements past uranium. So let's talk about that atomic structure. So atomic structure is composed of electrons, which are arranged in energy levels or shells around the nucleus of an atom. The energy levels and shells together are called the electron cloud. Electrons in the outermost shell are called valence electrons. So these are not all the electrons, these are just the farthest out ones. And valence electrons determine the behavior of an atom. Because valence electrons determine the behavior of an atom, all members of the same family have the same number of electrons because they all have the same behavior. The way to memorize the number of valence electrons that each family has is this little saying that I do. 1, 2, 2, 3, 4, 5, 6, 7, 8. Don't have to worry about the lanthanide and actinide series down there for now. So once again, because you need to have this memorized, the first column has 1, the second column has 2, all of the transition metals also have 2. Then when we bump back up, it goes 3, 4, 5, 6, 7, 8. So let's look at that atomic structure. This is an atom of helium. So you can see in the center, it has 2 protons, 2 neutrons, and 2 electrons in a shell going along the outside. This is a representation of a model of helium. So there are 3 particles that you just saw found in every atom: protons, neutrons, and electrons. Where protons have a positive charge, neutrons, neutral, have no charge, and electrons have a negative charge. As far as their mass is concerned, protons have a mass of 1 AMU, neutrons have a mass of 1 AMU, and electrons have a mass of basically 0. Does have a mass, it's just incredibly small. As far as where they're found in the atom, protons and neutrons are found in the nucleus together, so that means the nucleus has a positive charge and also has all of the mass of an atom. While the electrons are in that electron cloud around the outside of the nucleus, but do not account for any of the mass that an atom has. And just as a note, AMU stands for atomic mass unit. So let's talk a little bit more about the structure of an atom. So as I mentioned before, atoms are composed of protons, neutrons, and electrons. Where protons are positive, and we often abbreviate them with a P, and neutrons are neutral, which we abbreviate with an N, and electrons are negative, but we often abbreviate them as an E- to remind us. The nucleus is composed of protons and neutrons, and the electrons are in the electron cloud around the outside. Now, before we said that they were found in energy levels or shells, and that's what you're seeing in this picture, where different electrons are in different energy levels. And as far as our valence electrons are concerned, the farthest ones out, this one has 2, 1, 2, because they are the farthest on the outside is what we meant. So when you look at a periodic table, you often see in a box something that looks like this, where it gives you the element name, and then it gives you the atomic symbol, things you have memorized. But then you'll see a whole number, usually near the top, and that is the atomic number. That tells you your number of protons. Then we have your atomic mass down below. Keep in mind, if a proton is 1 and a neutron is 1, this number is collectively your number of protons and neutrons. So if you know protons, and you know protons and neutrons down here, you can figure out neutrons. Let's talk about that atomic numbers a little bit more. So atomic numbers are the whole number. And this is what identifies the element. Now remember, atomic numbers are your numbers of protons, so therefore it's number of protons that determines an element. The decimal is your average atomic mass, which means it is your protons and your neutrons added together. So once again, number of protons is the atomic number. Number of protons determines what element you have. The number of electrons will also be the atomic number if it's neutral. We'll talk more about that coming up, but if it's neutral, you'll have the same number of protons and electrons because you need the same amount of positive and the same amount of negative to be neutral. To get your number of neutrons, you're going to take your mass number, this number down here, and you're going to subtract your number of protons, which is this number up here. Because remember, your mass number is your number of protons plus your number of neutrons. And keep in mind, your mass number is the mass of one individual atom. All right, get out a periodic table. If you don't have yours handy already, go find it. And I want you to pause this video and answer the practice questions on the screen. I'm serious. Pause your video. Do not just wait for me to give you the answers. Pause the video and come back when you're done. All right, let's see how you did. You were asked how many protons are in zinc. You should have gotten 30, and that is because if you found zinc on the periodic table, it has an atomic number of 30. What is the atomic number of calcium? You should have gotten an answer of 20. What is the average atomic mass of oxygen? You should have gotten 16.00 AMU. That is the decimal point number, is always going to be your average atomic mass. Now 4 was a little trickier. It asks us how many neutrons are in lithium. The correct answer is 4. So you look at lithium, you see that lithium has 3 protons, and that it has an atomic mass of 6.94. We round that up to a whole number, which is going to be 7, and 7 minus 3 is 4. For how many electrons are in a neutral carbon? The answer is going to be 6, because remember, in a neutral atom, you will have the same number of protons and electrons. Now, number 6 asks you, why do the number of protons equal the number of electrons in a neutral atom? So electrons are negative and protons are positive. And the charges must be balanced out in order for it to be neutral. So you have to have the same number of negatives as positives if you want to have an overall neutral charge. How did you do? If you didn't do well, I recommend rewinding this video and watching the previous slides again before you move on, because we're only going to move on from here. So this brings us to something called ions. So if an atom gains or loses electrons, it is called an ion. When an atom gains or loses electrons, its overall charge is no longer going to be neutral because we do not have the same number of positive and negative. We call a positively charged ion a cation, and cations are usually formed by losing electrons, and when you lose a negative, it becomes positive. And negatively charged ions are called an anion, and anions are formed by gaining electrons, because once again, electrons have a negative charge, so when we add to them, you're going to go negative. So let's do a little bit of practice. If sodium loses an electron, what will its charge be? So we lose a negative. That means we're going to have a +1 charge. When you lose a negative, it becomes positive. All right, let's look here. 2 asks us how many electrons are in the following. And we have Cl minus 1 and Ca2 plus. So that number tells us the charge that it has, that this chlorine has a -1 charge and this chlorine has a 2 plus charge. So a -1 means that chlorine gained an electron because electrons have a negative charge. So you go on the periodic table and you find that chlorine normally has 17 electrons, but if it gained 1, that means it's going to have 18. Similarly, if you find calcium, you see that calcium normally has 20 electrons, but a 2 plus means that it lost 2, so it also now has 18 electrons. This is to show you that electrons do not determine what type of element you have. Both Cl-1 and Ca2+ have 18 electrons but are still separate elements. It is only protons that determine the element that you have. So let's talk about isotope notation / nuclear symbols. So this right here is a nuclear symbol and how you write one out. So let's look at what the different parts are. In the bottom, you're going to have your atomic number, and this is the number of protons in an atom. Up at the top, you're going to have your mass number, which is the number of protons and neutrons in an atom. We always round it to a whole number. Now keep in mind the number of electrons equals the number of protons minus whatever charge you have. Remember, if you subtract a negative, it's essentially like adding. So our charge right there is the number of electrons lost or gained. Remember, positive is when we lose and negative is when we gain. If it doesn't have a charge, you do not write 0. You just leave it blank. Then in the center of everything, you are going to put your elemental symbol, whatever that is for the element. Once again, nuclear symbols only contain whole numbers. We do not put decimals in nuclear symbols. You may also see on the following format sometimes where they do element name dash mass number. For example, oxygen dash 16 is another way that we sometimes write out elements. We're not going to be using it super commonly in here, but I did want you to be aware of it if you saw it in other locations. So let's do some more practice. Once again, I want you to pause this video and I want you to try it on your own. All right, up first, you were asked to write the nuclear symbol for gold. Since we weren't told anything about a charge or anything, we just looked over at the periodic table, and a correct nuclear symbol would have been Au, which is gold, with a 197 up top because that is the rounded to a whole number mass of gold, and then 79 in the bottom because that's the atomic number of gold. Number 2 asks us what the mass of chlorine is. And if you look on your periodic table, you will see that chlorine has a mass of 35.45. Now this one asks, which we would call 35. Now this next question asks you, what is the atomic number of chlorine 35? The atomic number of chlorine 35 is going to be the same atomic number as any other element of chlorine because protons determine our element, so it is going to be 17. 4 asks you how many neutrons are in uranium. So you find uranium on your periodic table, and you see that its mass is 238, and you subtract the atomic number, which is 92, and you find out that it has 146 neutrons. You're also asked how many electrons are in the uranium below, right over here. So you saw that it had a 3+ charge. That means that it has lost 3 electrons. So we take our 92, which would be our normal number of electrons and protons, and we subtract out 3. So 92 minus 3 means that you have 89 electrons. See? Not so bad. You've definitely got the hang of this. So let's talk a little bit more about atomic mass. So the masses of protons, neutrons, and electrons are expressed in atomic mass units, and it is abbreviated as AMU. The mass of a proton is approximately 1 AMU. A neutron is also about 1 AMU. An electron is almost 0. It's 1 divided by 1,836 AMU, so really, really small. Remember, the mass number of an element is the number of protons plus the number of neutrons, because those are the only things that really have mass in our atom. So this brings us to something called isotopes. So isotopes are atoms that have the same number of protons, meaning they're the same element, but a different number of neutrons. meaning it has a different mass. The difference between an element and its isotope is the mass number. Isotopes are going to have a higher or different, sometimes it can be lower, mass. You place the isotope's mass in the upper left corner of the chemical symbol of the element, even if it is not the one from the periodic table, because that just means you have an isotope, and that's not a big deal. So the mass number is the mass of one specific isotope. The average atomic mass, which is what is on the periodic table, is the mass of each isotope and how abundant it is in the universe. So it's our average of all of our different isotopes together. The average atomic mass depends on the abundance of each isotope. That means if an isotope is more common, it's going to affect the mass more than a less common isotope. Keep in mind that abundance is the amount the isotope occurs in nature. For example, for the abundance of lithium, lithium-6 is 7.59% abundant. Lithium-7 is 92.4% abundant. When you look on the periodic table, you see that lithium has a mass of 6.94%. That is because lithium-7 is so much more common that the mass is closer to that 7 than it is to the 6 because the 6 isn't near as common. You can calculate the average atomic mass of something following some very easy steps. You multiply the mass of each isotope by its percent abundance. Remember, percents are technically decimals, so 85% is 0.85, so make sure to put that in the decimal form. Then you're going to add all of your answers from number 1 together for all the different isotopes, and then you round your answer to 2 decimal places just like you see on the periodic table. All right, some practice with average atomic mass for you. Now note, just like from the last unit, you must show your work to use your notes on the note check. If you just have answers written down and you don't have any work shown, even if you did it in your calculator, there were air quotes around that, you will not be able to use your notes. You must show your work. All right, so we have a sample of cesium is 75% cesium-133, 20% cesium-132, and 5% cesium-134. What is the average atomic mass? If you need to, rewind to the previous slide, follow those steps, and come back when you have the mass. You should have gotten that the average atomic mass of cesium is 132.85. How'd you do? Hopefully you got it right. If you didn't, I recommend going back and trying the problem again following the steps from the previous slide. Let's try another one. You're told that carbon-12 is 98% abundance and carbon-14 is 2% abundant. Calculate the average atomic mass of carbon. Pause this video and come back when you're done. You should have gotten that your mass of carbon is 12.04. Now you may have noticed that these two numbers we got differ slightly from the values on the periodic table. That will happen, which is why it's important that although your answers should probably end up similar on problems, that you show your work and do the actual one, because if you just write down the number from the periodic table, it will be worth no points. Whew, that was a lot, but I think you've got the hang of it, and I look forward to practicing with you in class.